Assalamualaikum. My name is Nur Shamira Nadirah binti Mak Nordin. My matric number is B0621100031.
My name is Muhammad Kam Johari and my matrix number is B0621104994.
My name is Muhammad Farah Muhammad Sazli. My number matrix is B0621104415.
My name is Nurovana Btmi and my matric number is B0621101149.
My name is Rizwana Bani binti Abdullah. My matric is B0621102997.
Hi, Nurul Alin Tasha binti Azmi. My number matric B0621102121.
We from 3 Btmi S1 Group O will present about electric and electronic practice set C.
Okay, today I want to talk about introductions. The movement of electron is a component of energy in electricity. Atom which comprises elemental have a nucleus at the center. Neutron are changed, particle are not changed or better, which is positivity change, make a nucleus, negativity change, practice knowledge, electron around the nucleus and alpha atom. An atom typically contains the same number of proton and electron because the negative change of an electron is equal to the positive change of the proton. Of that, machines that transform mechanical energy into electrical energy is called an electric generator. The machines release on the connection between electric and magnetic. An electric current flow through a wire or any other electrical conductive substance when it passes through a magnetic field. As a result, certain bonding like current stabilizer structure and storage area that would have included all the necessary electrical data. It becomes challenges to manage electrical utilities when trying to get electrical and data for specific bonding from various places and sources. Even some bonding prevent the interference of computer.
Now, I would like to talk about the methodology. First, DC voltage level. Establish the necessary amount of voltage regulation and find out how much current the device draws. Finding out the precise power needs of the equipment being powered is the first step. One of the most important approaches is figuring out how much power is needed. Second, select a suitable topology for the power supply. The demand device determines which power supply architecture is best. Simple circuits called linear regulator modify voltage by using transistor and resistor. Although they produce heat and waste energy, they are effective for low power application. Then, switching regulator are more intricate circuits that quickly alter the input voltage using transistor to provide a controlled DC output. Choosing the appropriate parts, making the correct component choice is essential for a power supply that works well. Transformer may be thought of a musical conductor, tuning an instrument like voltage by raising or lower its level. Rectifier establish the beat, transforming the oscillating wave of AC into throbbing DC rhythm. The sound is smoothed out using filters. Just where audio professional refine DC to a constant hum. The band is led by a regulator who maintain precisely calibrated voltage. And lastly, multisim. Testing and simulation are two main strategies. In this work, simulation tools like multisim are used for performance analysis and design optimization. Test the built circuit thoroughly to ensure it meets the criteria. Finally, since safety is our first concern, we only employ components with the proper voltage and current ratings. Put isolation between the input and the output in a place in addition to overcurrent and over voltage safety.
Figure 1. In this circuit, we're looking for the left to the right component. First component is AC source, 240 volt RMS and 50 Hz. And next, the transformer component, 10 to 1 value. Next, the diode, have a 4 bridge resistor composed of the value 1 and 4002 G diode for the level D1, D2, D3 and D4. Next, the capacitor component. The first is the largest capacitor component that have a 2 value, is 2200 UF. Level is in the circuit is C1 and C5. This value capacitor help to smooth out the fluctuations in the voltage supply to the circuits and reducing reply and noise. And smaller capacitor for additional filtering, the value is 0.12 UF. Is the level C2, C3, C4, C6 and C7, C8. Next, the voltage has two regulator, U1 and U2. Is representing positive 12 and negative 12 volts. The two is about how we measure the circuit. We measure the circuit using by two pieces of equipment. First, oscilloscope and multimeter to get the result about voltage, current and sinusoidal waveform. And also, we measure by using probe to get the VRMS and IRMS for each output of component like diode, capacitor and transformer. Figure 3. Figure 3 is a result and oscilloscope. The first and oscilloscope is to be connected to the input wing. So an oscilloscope have two channel, channel A, channel B. In channel A, positive we connected to the AC source positive and channel A negative we connected to AC source negative. This value is a 240 VRMS and 50 Hz. And then the channel B, positive we connected to the transformer input and channel B negative we connected to the output. So the result of the first and oscilloscope is we get 359 volt as a peak value and 33 volt for channel B. On secondary reading, it should step down the voltage by a factor of 10 to 1 voltage by referring to the channel V, the peak value of 33.993 volt and the peak to peak value of 63.32 square root of 2 equal to 33.90 volt. Figure 4, the result of a second oscilloscope. This oscilloscope is connected to the output. In channel A positive connected to the output positive 12 and the channel A negative connect to the ground, while channel B positive connect to the negative 12 volt and negative connection to the ground. On this connection, we can know that draw circuit is correct from the beginning until the end of the circuit. The result we can get channel A 12 volt and the channel B negative volt because of the component of transformer. This transformer can use for electrical circuit to change the voltage or the current following within circuit and used to increase or decrease the voltage in an AC circuit. Figure 5, the result of the multimeter. We use two multimeter. First multimeter connected the output voltage. Positive multimeter connected the output and negative connected the ground. Second multimeter, positive connected the output, negative 12 and negative connected the ground. The result we can get is first 12 volt and the second negative 12. In this result, multimeter can say that the value are correct in the circuit because the value output get the same of the voltage value.
So first of all, I will introduce our creative solution proposal. The first proposed solution is multi-level switch capacitors, where it have multiple stages of capacitors to increase efficiency and flexibility to adapt for that more diverse power supplies. Second is wireless power transfer, where we will use less wires and transfer power directly over short distances, which will reduce clutter and increase our safety design. And lastly is gallium nitride or GaN, which will reaching power complex supplies with minimal heat dissipation and achieve better efficiency. So advantages and challenges for multi-level switch capacitors. We will have an incredible 90% efficiency with flexibility and adaptation to diverse power needed. And the challenges will be complex and needs precise control and balancing for the capacitor itself, and it will have high initial cost investment. So the second is wireless power transfer. For advantages, it will create many possibilities in a lot of sectors, including medical and manufacturing. And it will also reduce waste on wires and materials. But there are also challenges in which it have lack in compatibilities of components, and it is also lack of technology in the field itself. And lastly is GaN or gallium nitride, which it will push the efficiency to 95% efficiency. And lastly, it has sleeker design and lighter design because of its reduced and compact component itself. And the challenges will be high initial cost, and it's more complex than the existing power supply in the market right now. So next is eco-friendly components, where gallium nitride or GaN creates a smaller carbon footprint. Thus, due to its compact nature, smaller components or reduced component in power supply will directly translate to reduce in lead solder, which is better for the environment. Higher efficiency translates to reduce in energy consumption. Thus, it will reduce the greenhouse gas emissions. Next is reducing e-waste components such as electronics and recycling it for future use. And lastly is cut down on plastic waste. So lastly is sustainability assessment. For environmental impact, we will reduce carbon footprint, minimize waste, and lastly enhance brand image for the customers and consumers. The second is economic impact, where we will reduce our costs and increase our cost saving, increase our competitive advantage over other competitors. And lastly, regulatory compliance, where we will follow the regulatory and thus preventing any fine for us. So lastly is global goals and alignment, which we will align with multiple national treaties, such as example United Nations SDGs, Paris Agreement, and regional regulation, especially Asian regulation. Thank you.
I will continue the discussion and analysis, which is the end-of-life consideration. The purpose of power supply design also excel in considering the end-of-life stage of their component multi-level switch capacitor convert, such as the first, component level recycling. Individual capacitor can be readily sprayed and recycled through established electronic waste. If the second, wireless power transfer and inductive charging. Standard coil. Promote the adoption the standard charging coil in increase interoperability and reduce the need for frequent replacement. And third, gen-based switch lead topologies, higher reliability gen transistor procedures, less band copper the silicon counterpart, reduce the need the frequency replacement. Next, implementation strategy. Will this design offer undeniable benefit in terms of efficiency, sustainability, and market differentiation? Integration them into increased manufacturing process. Define a strategy approach. First, multi-level switch capacitor convert. Challenge balancing and control multi-capacitor voltage with authors versus specialized interest and test equipment. Strategy to bridge the skill gap. Consider with talent acquisition, the cooperation innovation. Second, the last cost benefit analysis. Choosing between the traditional and innovation power supply design often high and on the delicate balance between initial investment, operation cost, and long-term benefit. Initial investment, traditional Typical lower upgrade cost due to the established technology and readily available component. Innovation, generally high intentional investment due to the technology's specialty component and functional highest design complexity. Second, operational cost, traditional, lower intentional efficiency can translate to higher energy consumption and large electric bill over time. Innovation, higher efficiency lead to significant energy saving in the long term. Third, long-term benefit, sustainability. Innovation design contribute the reduced greenhouse gas emission, resource conservation, and waste minimization, aligning with global sustainable goals.
For our conclusion, our modern world hinges on the steady hum of electricity, and the heart of this intricate symphony lies the humble power supply, often overlooked. This using heroic silent convert raw AC electricity into the DC lifeboat that fuel our device. Yet, the future of power supply is far from static. This exploration has delved into the world of innovative design, unveiling a constellation of possibilities that promise to make power supply smaller, smarter, and greener. By understanding the nuance of each design, we can make informed choice about which solution best suit for our specific need and prioritize. The future of power supply is no longer a nebulous vision. It's a tangible reality can be grasped and shaped, where the prioritize agility and freedom, electrifying performance, the innovative design offer a glimpse into the brightest, more connected world, powered by responsible innovation. That's all from us. Thank you.